Hello again, everybody. Welcome back to a new screencast lecture. Today's topic is kinetic energy. Let's get started. Let's start with a real quick pretest question. Go ahead and read through this. This says a ball is released from rest at position 1. So right here. The diagram shows the ball in 4 positions as it rolls down the track from left to right. So it starts here, goes down to here to part 2, down here to point 3, and then starts going back up the hill to point 4. The question is, in which position does the ball have its minimum gravitational potential energy and its maximum kinetic energy? Go ahead and write down an answer for what you think it is now, A, B, C, or D, and we will check the answers at the end of this 3-part lecture series about kinetic and potential energy. Let's move on. Time for a quick review, some important vocabulary and ideas. Let's define the word energy. Energy is the ability to cause a change. Let's look at an example of something changing. Think about the energy that is causing the changes. Let's start. Okay, take a look at this. What is the change? The change is the tree branches moving. Now, what is causing that change? Where's the energy coming from? If there is a change, we must assume that there is some energy being spent. And in this case, the energy is coming from the wind. Now, let's talk about the 2 general energy types. The 2 general energy types are kinetic and potential. Today we're going to focus on kinetic energy. Kind of a shock since that's the title of the lecture. Okay, let's get a definition for kinetic energy. Kinetic energy is the energy an object has due to its motion. Usain Bolt, fastest man in the world. Here's a clip. This is a video clip about kinetic sculptures. These are pieces of art that move. A fun fact about this artist, I was reading about him. Apparently he sold some sculptures for over $450,000. Pretty good. Now, there are 2 variables in kinetic energy. Let's talk about the first one. Well, which has more kinetic energy? The ball after it's bunted. There's a bunt. Or the ball hit on a line drive. Which one has more kinetic energy? Well, the line drive has more kinetic energy. Why does the line drive have more kinetic energy? The line drive has more kinetic energy because the ball is moving faster. The ball is moving much faster when the ball is hit on a line drive than it is when it is bunted. To increase kinetic energy of an object, I can increase the object's what? Well, I can increase the object's speed. If I increase the object's speed, I'm also increasing the object's kinetic energy. The first variable in kinetic energy is the speed of the object. Let's get to variable number 2. Let's think of it this way. Let's consider 2 golf balls. Take a look at this guy. This is pretty neat. Impressive. I'm not any good at golf. Let's say you have 2 golf balls. These are both the same volume. They're both the same size and shape. The wiffle ball on the left versus a real golf ball. Imagine these 2 objects are going at the same rate of speed, say 20 miles an hour. Which do you think would have more kinetic energy and why? Well, if you said the real golf ball would have more kinetic energy, you'd be right. The real golf ball has more kinetic energy because it has a greater mass than the wiffle ball. So for variable number 2, if I wanted to increase the kinetic energy of a moving object, I can increase the object's, that's right, mass. The next clip is a video I made of 2 swinging pendulums. They are both released from the same height, from 10 centimeters. so they will both be falling at the same rate of speed. One weight is 100 grams, and the other weight is 10 times larger than that, so 1,000 grams. Which weight do you think will swing for the longest amount of time before it stops swinging? In other words, which will run out of energy last? Which one will remain swinging for the longest period of time? Here's a clip. Okay, I hope you like that. I thought that was pretty interesting. You can clearly see that the larger mass ran out of energy way after the small mass ran out of energy. So 8 minutes swing time for the small one. Definitely would have been over 40 minutes for the larger mass. It was definitely not even close to being stopped swinging before the student ran into it. So that's a good experiment to show that the more mass the object has, the more kinetic energy it's going to have. Okay, guys, that's all we have for today. I hope you enjoyed it. I hope you catch us next time for the lecture that's going to be on potential energy. See ya!